Welcome to another episode of Ruddle on Shape Clean Pack. Today I'd like to speak about access preparation. When we think about preparing access cavities into any tooth, it's going to be important that we have a few ideas in mind and a few concepts to help us be successful on each and every case. As you can see, we'll access maxillary anteriors, we'll look at a few maxillary posteriors, we'll look at some of the mandibular anteriors, and then we'll finally look at some access cavities into the mandibular posterior teeth. Let's get started. I've often said that perhaps the most important thing we as endodontic educators do is when we teach access preparation. The size of the access cavity is not a universal agreement. In fact, you tell me where you went to dental school and I'll tell you how big you were trained to make your preparation window. But if we think about general dentistry, it's quite interesting to borrow some of those concepts that have been so useful over the last 100 years. As an example, when general dentists finish cutting a crown preparation and they hang up their handpiece, typically what they do is they look in the mouth mirror. And they're looking in the mouth mirror to observe, do they have draw? You can use this same analogy when you look into your finished access. If you can look into your mouth mirror and without moving the mirror, if you can see all the orifices in a multi-rooted tooth, you have great straight line access. On the contrary, if you have to move your mirror to see each individual orifice, you're underprepared and the window at the top of the tooth is too small. The axial walls need to be flared back so we can get straight line access. So use the mouth mirror trick and you'll find that your access cavities will expand somewhat. By expanding your access cavities, you're going to have greater success in all your future endodontic endeavors. Another analogy that is quite useful that we can borrow from general dentists is the wax pattern idea. In other words, once we have an impression on a prepared tooth, typically the impression is taken to a laboratory, it is poured up with dental stone, and at some point the stone is utilized to fabricate a wax pattern. That wax pattern needs to draw off the stone die so that we can sufficiently cast it and go back to the mouth and seat that restoration at a later time. We can use again this same analogy as we use in restorative dentistry, and we can take it to our endodontic access preparations. In this analogy, the rhetorical question is, are you able to withdraw a wax pattern out of your access preparation without distorting the wax? To the extent you can begin to remove wax patterns in your mind out of your access cavity, you're going to also confirm that you have straight line access. Well, there's a few tools that we would all agree that would be very useful to have if we were going to do access preparation. Certainly the dental operating microscope is a very invaluable tool to help us see big and bright. But beyond big and bright, we can see color and texture as well. Certainly it emphasizes chair position, lumbar support. We can support our arms. If we use the Zeiss Pro Ergo, we have pistol grip handles that allow us to zoom in on the field of action. Whether you're using a global or a Zeiss, a Seiler, or any number of microscopes that are available today in the marketplace, we would all agree they bring something very important to the game of access preparation. There's not too many burrs that would be called upon to be utilized to prepare an access in any tooth. Typically, accesses can be cut and be completed in a very nice way with just 2 or maybe 3 instruments. So here you can see there's an access burr kit by Dentsply Tulsa Dental Specialties, and you can see there's a variety of burrs, but even though we have a variety of burrs, we're usually using just 2 or 3 burrs. Let's look at these burrs a little bit closer. We're going to go from left to right, and you'll notice as we go left to right, the burrs get longer as we move towards the right of the choices. As an example, we need a number 2 and a number 4 round burr diamond to get through tooth-colored restoratives. I use the larger number 4 to get through the occlusal tables of posterior teeth. On the contrary, we'd use a number 2 to get into bicuspids and anterior maxillary teeth and mandibular teeth. Using a number 2 is more appropriate because these teeth have smaller occlusal tables Their cervical nicks are smaller, and so this is more appropriate, so we maximize remaining dentin. Well, a transmetal burr is a useful burr because it removes a lot of the unwanted vibration. When you're making an access cavity through amalgam or through a precious and non-precious metal casting, oftentimes there's vibration, especially when there's a hot tooth. These vibrations can mean the patient will complain that they're not profoundly anesthetized. So even though you might need to give a interligamentary injection or a Stabident or some kind of an auxiliary injection to your block anesthesia, one of the ways to manage discomfort is to use a sharp sawtooth type cutting blade where we can reduce the unwanted vibrations. We use a surgical length number 2 and number 4 round burr diamond. Again, the number 4 is appropriate for molar teeth, whereas the number 2 is appropriate for the bicuspid and the anterior teeth. The surgical length idea is important because it kicks the handpiece further away from the occlusal table. And by removing the handpiece away from the occlusal table, we get a preferable line of sight down the burr so we can watch the burr actually work. The Endo-Z burr is an important burr in that it is safe-ended. It is the number 1 burr in dental schools in North America because students can put the end of the burr on the pulpal floor in a furcated tooth. They can move around the access cavity and cut laterally to clean up the axial walls and flatten them. I personally, I should say, don't use the Endo-Z burr because I prefer a burr that not only is lateral cutting but in cutting as well. And that brings us then to the surgical length diamond. It's the only diamond in the business that has 13 millimeters of cutting grit, so we can cut the lateral walls flat, and we can also in cut with a diamond to chase grooves or remove a pulpal stone that might be attached to the pulpal floor. It's really important to finish access cavities. Anybody can basically make a hole in the tooth, but your great clinicians finish those holes exquisitely because a flat axial wall refracts light, and when we refract light, we see fractures, we see little nuances that can help us be better diagnosticians. Well, the last burr looks like a Gates Glidden to you, but it's really not. In fact, what it is, it's an X Gates. X means auxiliary. The auxiliary X Gates has 4 Gates Gliddens on its cutting blades. So you can see we have a GG1 equivalent to a 1/2 millimeter and a GG2, 3, and 4, and you can read the metric relationships between the GGs and their maximum cross-sectional diameter. I'm showing you the width of the Gates Glidden equivalent on the auxiliary X Gates, but you should know that the entire head is 4 millimeters in its overall length. That'll be important in just a few moments. Well, when we begin to look at this animation, if we do a cross-section through the mesial root, what you immediately notice as a colleague is that the canals at this level of coronal slice are not centered in the mesial distal dimensions of the root. In fact, the way the canals enter into the pulp chamber, it means the canals are a little bit off axis. They're not centered and they're skewed slightly towards the furcal side concavity. This means there is importance in relocating those orifices away from furcal danger and to end up with a final prep where the orifices are centered in the mesial distal dimensions of the root. Too often, over time, colleagues have simply put a rotary file into an orifice and started shaping, but those instruments primarily shape around an axis of orientation, which means that the final preparation drifts closer to the furcal side concavity. This can lead to root thinning and a predisposition to longitudinal fractures, or there can be an overt strip perf. So the 3 things we want to do with an auxiliary X Gates is we want to flare the orifice and put a mouth on it. This will simplify all subsequent procedures because a flared orifice more readily receives instruments. We want to remove triangles of dentin. All teeth have triangles of dentin, and these triangles of dentin are what push the handle on the hand file off axes and make the hand file come in at an awkward angle. So by removing triangles of dentin, we can upright those handles so we're on axes. Finally, as we just mentioned, we want to relocate the orifices intentionally away from furcal danger. Now, something to say about the X gates is when we have a handle that is off axis, you can see the triangle of dentin that is kicking that handle in this awkward way. What we would do then is we would use the X gates. The X gates is used at 500 RPMs. Notice we're reducing its RPMs. You can see when we're spinning it, you can even see the blades turning around. It is dangerous to use these at high RPMs, like 2,000 to 2,500 RPMs, because they get grabby and they'll get sucked into the canal. So by slowing down the X gates, it's not grabby. The second major thing to emphasize, it's a brush. So by brushing out of the canal, what we're doing is progressively removing the triangle of dentin. We're achieving straight line access to the orifice, and we're restricting that tool so its head is only 1 bud depth below the orifice. Well, there's other ways we can flare the orifice. Some colleagues prefer to use the ProTaper auxiliary shaper, or Shaper X. SX can be used at 300 RPMs and at 520 gram-centimeters of torque to do the same thing I just showed with the X gates. So you have a choice on how you can do this, and there's a variety of tools and methods that can be used to safely accommodate flaring the orifice, removing triangles of dentin, and relocating the orifice away from furcal danger. The one thing to emphasize with the auxiliary shaper is be sure to put a tin file into the canal first to make sure there is sufficient working width so the tip of the instrument is not going to engage and cut dentin. In fact, the tip of the instrument should just follow. There should be enough working width to accommodate its working end. And the end is just the steering wheel on the nickel titanium car. It steers the instrument through curvature, but you're pushing the workload up to the bigger, stronger, and more efficient blades. That's a very effective way to pre-flare the orifice and begin to remove restrictive dentin from the coronal 1/3 of any root. Once we have finished removing triangles of dentin, you can see how the tin hand file has been uprighted, and we have now both coronal and radicular access. What I'm really emphasizing is everybody in the world is focused on getting coronal access, but I want you to start thinking about getting radicular access. So there's two kinds of access, coronal and radicular, and when we get both, you'll find that all subsequent steps of endodontics become much more straightforward. Well, here's a slide that if you look at the red dotted lines, you'll see that they're coming off the mesial and distal surfaces of the clinical crown. And you can see that the distal root lies outside those dotted lines. In this instance, when the roots do not lie underneath the circumferential dimensions of the clinical crown, you can still have a file come out off axes, but it can actually be on axes to the root. So the take-home message is, if the roots lie underneath the clinical crown, then straight line access is observed when the handles stand up straight and tall. You can also have straight line access even when the handle comes out off axis if the roots aren't underneath the dimensions of the clinical crown. Let's come back to the furcal side concavity. You can see in the inset image there is a strong furcation, and again, as we've noticed earlier, the canals are not centered in the mesial distal dimensions of the cross section. If you look at the radiograph, you can see that there's a big furcal lesion. There's a gutta-percha point that's tracing through the sulcus buccal, and it traces to a lesion of endodontic origin. You can notice in this image that there is quite a furcal side concavity, and you can begin to notice the coronal aspect of the canal and how it awkwardly bends into the pulp chamber. It's going to be really important then to think about getting great access and de-roofing, flattening out those axial walls, but we now need to remove a big long triangle of dentin. And let's take a look and see how that might be accomplished. But if you look carefully at the cross section, I want to bring to your attention on the left would be the correct method. That would be brushing and relocating the canal away from the furcal concavity. It means that there'd be more residual dentin and the canal would be more centered in the mesial dimensions of the root. If you look at the shaded gray area on the right, you'll notice that although we're perfectly circumscribing the canal, the preparation is definitely much closer to the caval surface of the root, and this is the danger that we spoke about. Well, there's evidence for what we do, and the evidence is something that's important to review so you can kind of put it all together. The Catholic University of Leuven sends me the tooth on the left, and they remove the distal root. And in this case, what you're noticing on the left image is the image that you would pretty much see if it was a radiograph. You can get a hint that there's a furcal side concavity. On the right, though, if we flip the tooth 90 degrees and it's rotated, you can see that there's a fairly strong concavity. So this was published in a peer-reviewed journal, and we did micro-CT analysis with the Catholic University of Leuven to better appreciate what I just talked about. So if you look at the image on the far left, you can see the yellow cross-section through the coronal aspect of the tooth, and at that section you can see on the right image green. Green is before Cliff Ruddle, and that's how the canals would have actually looked before anybody ever went into the tooth. Red is after Ruddle, so you can see that Ruddle has intentionally moved from the green areas to the red areas, and I've pushed the orifice away from the furcal side concavity. That's all done with either an auxiliary ProTaper Shaper X, or you can do it with an auxiliary X gates. And you can see the big work is done with a surgical length tapered diamond. So move your big axial walls with a tool that can do it efficiently, but drag your orifices and relocate those with either Shaper X or the auxiliary X gates. If you look at the micro CT, green is the original pathway coronally of the canal, red is the little job that we did with the tools just described. It's useful when you're looking at access cavities and thinking about the procedure to have piezoelectric ultrasonic generator aboard. A generator allows you to use insert tips that can do very precise work. What this handpiece allows us to do is to thread on some insert tips so we can do a little job very precisely. In the context of this presentation, we're usually working on the P5 piezo booster at about 1, 2, or 3. Certainly use low power or low intensity settings so we don't prematurely break instruments. These are some sine tips that I've invented. As we know, there's a piezoelectric wave of energy that goes through these insert tips. It's sinusoidal in nature, but the sine 1 tip is pointed, and so that can work in grooves and fissures off of systems, like an MB2 that emanates off an MB1 in a maxillary first molar. The sine 2 has a radius tip that's equivalent to a 35 file, and then we have a sine 3 that has a 0.5 millimeter ball. A sine 4 has a 3/4 millimeter ball, and the sine 5 is equivalent to a GG2. That would be 0.7 of a millimeter. And finally, the sine 6 is equivalent to a GG4, which is 1.1 millimeter at its maximum cross-sectional diameter. These instruments have a double diamond composite coating, and what that means is they're very durable and very efficient. And if we look at their efficiency, all we have to do is look at the left, and you can see that in 450 microns of real estate, there's about 140 tips that the computer can count. And when I say tips, I mean tips. You're looking at the tip of a diamond. So those are diamond particles, and there's 140 diamond particles per 450 microns. If you look at the two images on the right, these are competitor tips, and you can see that there's about 50 diamonds per 450 microns. So the sine tips have almost 3 times more particles per unit area than any of the competitive tips on the market today. That means and prognosticates that they're going to work very efficiently and again at low power. Many of you are aware of the Stropco adapter. What we do in the screen back image behind is your triplex syringe, and you can take the stem out of it and permanently discard it. And what we do is insert a Stropco 3-way irrigator, and by quick inserting it into your triplex syringe, then you can have a lure lock thread system on its distal end, and you can use a variety of different insert tips to thread in there, and this way you can collimate air only, as you're seeing in this image, or air and water, or water in a very precise way. Collimating air and water into the field of activity means less aerosol and better visibility. Okay, we've looked at several tools that can be utilized to cut and finish access cavities. Hopefully, the tools that you've seen in use will give you some ideas about how to more competently prepare your access cavities on a go-forward basis.